Okay, so in this video we're going to go over solving logarithmic equations. So to this point we've looked at solving exponentials, right, where our functions had the value that we're looking for, the unknown, in the exponent. But now we're going to take a look at, well, what if we add logarithms that variable was inside a logarithm to begin with. So let's look at 6 plus ln of x is equal to 10. Okay. Excuse me. All right, so the first type of equation is we're going to use the definition of a log, right? So in order to do that, I want to get the log of whatever expression we have inside here, and then everything else on one side, right? So this will work when there's only one logarithm with the variable inside of it, right? If there's two logarithms with the variable, we could still take this approach, right? Because we can use the power rule or the quotient rule to combine these, right? Now, if the constant value, like if they all had logs, then we take a different approach, right? But for something like this, where my first step would be, let me subtract 6. Okay, so I've isolated the natural log. And again, remember this natural log means log base d of x is equal to 4. And using the definition of the log, remember the result of the logarithm is an exponent. So the way we can rewrite this, right? This is true because e to the 4th is equal to whatever that value is, right? So our solution is simply this, right? X is equal to e to the 4th, right? And we can see here, just a quick mental check. If we plug that in here, e to the 4th, right? Natural log, we can bring the 4 out in front. Natural log of e is 1. You get 6 plus 4 is 10. All right, so that checks out, right? So that would work here, right? When we have the when we're using the the definition of a logarithm, right? When we have one logarithm, right, and constants everywhere else. Now, let's say our equation looked like this: log base 2 of 2 minus x plus log base 2 negative x is equal to 3. So here what we're going to use is the one-to-one property of the logs, right? As we discussed when we were talking about these exponentials, the logarithm is also a one-to-one. So it passes the vertical and the horizontal line test. But in terms of algebraically, if we have a statement like this, right, what we have is, excuse me, I think I miswrote this here. Sorry, let's backtrack here. We're not going to quite use the one-to-one property here. Okay, we're going to still use the definition of a logarithm, right? But before we can do that, I want to make it look like this, where we just have one logarithm and then a number constant here on the other side. So what I'm going to do to achieve that is I'm going to use the sum rule, right? The product rule, I should say. So now I can write log base 2, and I'll have negative x times 2 minus x is equal to 3. All right, and using the definition of a log, we have 2 raised to the 3rd power. So on this side, we'll have negative x times 2 minus x equals to 2 to the 3rd power. Okay, so now let's start by distributing. Looks like we have a quadratic. Right, so I'm going to set this equal to 0. So we'll have x squared minus 2x. I'll bring the 8 on the other side. And the first thing I always want to do is, can I factor this, right? And it looks like I can. Right, so this can factor to x minus 4, x plus 2. Okay, so just doing a quick check, x squared positive 2x minus 4x gives me a negative 2x. And then negative 4 times 2 gives me a minus 8. All right, so everything looks good here. So here I have x equals to 4 or x equals to -2. Now, when dealing with values, variables inside the logarithm, we do have to be very careful here. Let's go back here and make sure that these are going to work out. So if I plug in a positive 4, 2 minus 4 is -2, so that's undefined, so that is not going to work. So, okay. Here, so that's not part of a solution. -2, so 2 minus a -2 is 2 plus 2. That's 4. That's good. So let's check the other one. All right, -2 and -2 is +2, so that also checks out. So in this case, we have one solution. X is equal to -2. Okay? All right. So it's important here when dealing with logarithms, especially with variables inside the logarithm, to make sure that you check your answers. All right. Now notice here, just because you see a minus there, that does not mean that there is a no solution there. Okay. The argument together needs to be positive, right? Which is why that -2 works here in both cases. Okay. All right. So that is solving using the definition of a log. Now, as I was getting ahead of myself earlier, now let's use the one-to-one property to solve logarithmic equations. Right? So those will look more like this, right? Let's say we have log x plus log x plus 1 is equal to log of 2. Okay, so again, no base is written out, though it is assumed that we have the common logarithm here. Now I'm going to use the one-to-one property. So what that means here is, let's say we have an equation like this, right? Log of t equals to log of s. All right, so that's our equation, right? Two logs, one on each side of the equation with the same base. So just to generalize it, let's say a base b. If we have something like this, then it must be true that t must equal to s. So we're going to take advantage of this one-to-one property here to solve this equation here. Right, so I'll start by again using the product rule here. So this is log x times x plus 1. And here on this side we still have just log of 2. All right. And now we have this relationship here. Right? We have a log equal to another log. So what must be true is that the arguments, in this case x plus 1, must equal to 2. Okay, and then distributing here. So now it becomes, looks like I have another quadratic. So now I use techniques that I've used in the past, right? Set this equal to 0. All right, first thing is, can I factor this? And it looks like I can. X minus 2, x plus 1. Reverse. X minus 2. The middle term is positive, right? So we get negative x plus 2x. That gives me a positive x. The last term is -2. First term is x squared. Okay, so looking at this, we get x is equal to -2. X is equal to 1. Again, do a quick check here. I see -2 is not going to work here, right? The argument can't be negative, so right away I'll reject that solution. 1, when I plug it in here, that works. This works as well here. So now we have our solution. X is equal to 1. All right, and that is how you use the one-to-one property to solve these logarithmic equations.